Okay, so we're back and we're still looking at this problem. And when I see something like this, g of blank is equal, well, g of x is equal to ax squared plus 24, I consider this to be g of something is equal to a times that thing squared. Notice I'm just replacing the x. Plus 24. Now the thing is, when you usually see this, you'll usually see a value here. You won't usually see two variables. And so they're telling us secretly, hey, this a is a constant, it's a regular number, and if you were to put 4 right here, let me use a colored pen. If you were to put 4 here, this whole thing, g of 4, would equal 8, meaning 8 would equal to a times 4 quantity squared plus 24. This is multiplication. So what this is giving us is an opportunity to solve for that a value, right? So 8 is equal to 16. This 4 squared, this little 2 only deals with the 4. It doesn't deal with the 8. So it's 4 squared times a plus 24. If I'm going to solve this, I'm going to move some stuff around. Subtract 24 on both sides. I'm going to get a negative 16 is equal to 16a. Therefore, a is equal to negative 1. Now that I have that, I can rewrite this bad boy as g of x is equal to negative 1 times x squared, right, plus 24. So I can do that. This red is annoying me. It's a little too red. So I'm going to go back and we're going to work on this. So g of x is equal to that. That is now, we've defined what a is. So now we can calculate what g of negative 4 is. Remember what I said before? G of blank is equal to, in this case now, negative 1 times blank quantity squared plus 24. I'm going to plug in that negative 4 here so we can analyze what's going on, and we see that it's not too bad. Negative 4 quantity squared is 16. Again, that 2 just deals with the negative 4. When I square that negative 4, I get 16 positive, but then when I multiply by negative 1, I get a negative again. So g of negative 4, the thing we're solving for, is equal to negative 16, because I squared it and he made a negative again, plus 24. When I add those together, I get a negative, positive 8. And I just realized I did not give you the answer in the beginning, and so that's my bad. All right, so that's number 10. Let's look at number 11. The answer, let me give you that first, is D, and so the answer is D, and so how do we get there? So if in the equation above, B and C represent the price per pound in dollars of beef and chicken. So that's price of beef, price of chicken. And X is the number of weeks after July 1st during the last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? So if the price per pound of beef is equal to the price per pound of chicken, then what we need to do is set them equal to each other, okay? So 2.35 plus 0.25x is equal to 1.75 plus 0.4. I don't need to put anything else. I'm just going to put 0.4x. Is that okay? I hope that makes sense. All right, so we need to solve this equation. If you're feeling comfortable to deal with decimals, then rock out. If not, you can multiply this whole thing by 100 to solve for x. I want to caution you, solving for x is not going to give us the answer to the equation, but what it will do is tell me like the number of weeks after July, blah, 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 and then it'll tell me when the prices were equal. So after I solve for x, I'm going to have to put that value back into the equation to solve for the actual problem, because they want to know the price per pound of chicken or beef during this time when they were equal, okay? So if I solve this, I'm actually not, I could multiply everything by 100, but I'm not going to. I don't think we really have to. But if I did, then the decimal place would move over and I wouldn't have any decimals, which makes some people feel satisfied. But you would have a calculator, so you'd be cool. All right, so when I subtract 2.35 minus 1.75, I don't even remember what I got last time. I think I got, let me go back. Look at me. 1.75, I'm ashamed that I'm using a calculator. 2.35 minus 1.75, I know I could do it, I promise I could, is equal to 0.6. So when I subtract these guys, I get 0.6, and then I'm going to have to subtract this guy, 0.25x, over here, and I'm going to get 1.5x. At this point, I'm going to divide both sides, by 1.5, and x is equal to 4, which is not the answer, right? It's not the answer, but it tells me how many weeks after July 1st it took for the prices to be the same. So I'm going to plug it in. Now I can plug it into either one and I will get the same value. In fact, that's the whole point. I should get the same B and C value if I plugged it into either one. So when I plug it into the top one or the bottom one, I found out that my answer was $3.35 just by plugging in the 4, multiplying. Like 4 times 25 is $1, $1 plus 235, blah, 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 blah. All right, good stuff. Let's look at number 12. And I'll give you the answer. So the answer to this one is D. And a line in the XY plane passes through the origin. Do we remember what the origin is? Origin is 0, 0, that center place. So I'm going to draw a quick picture of what this could look like. So right there, we know there's a line in this XY plane. This is X, this is Y, and it passes through the origin. And it has a slope of 1/7. Which of the following points lies on the line? We need to remember that 1/7 is my rise over my run. Okay, and if I were to take a look at this, I need to process it thinking about it that way. So up 1/7, up 1/7, that's how I'd get my point. So up 1 over 1, 2, 3, 4, 5, 6, 7, boom, that's a point. Up 1 over 1, 2, 3, 4, 5, 6, 7, that would be another point. So this is what my line would look like. Let me use a different color there. I had problems drawing lines. Yeah, that was bad. Okay, so that's what my line looks like. So which one of these points could possibly be there? 0, 7 is up here. That doesn't make sense. 1, 7 is also up here. That doesn't make sense. 7, 7 is like right here. That doesn't make sense. Look, all of them will go up to 7. And this is 14 out to 14 up to, which makes perfect sense. And we see that it lands right there on our line. All right. Number 13, we are getting to the end of this section. Number 13, if X is greater than 3, which of the following is equivalent? Let me give you the answer and then we'll talk about it. Okay, so my answer is B, and we're gonna talk about it. Which one of these is equivalent? Couple ways to do this. If X is greater than 3, which of the following is equivalent? Basically, you can put a number in to kind of solve it. What I did is I kind of just did the algebraic process and I kind of worked through it. But I think plugging a number in might be greater. So it says, if X is bigger than 3, which of the following is equivalent? Shove a 4 in there and do your thing. So if I put a 4 into the original equation, I would get 1 plus 4 plus 2 plus 1 over 4 plus 3. And this would be 1 over 1/6 plus 1/7. And so now the key here is that I got to kind of reduce this bad boy, move things around to make sure it makes sense. Let me show you a quick way to handle disgustingness like this. What you could do is multiply, this is a complex fraction because it's got fractions within the fraction. You can multiply the top and bottom of the larger fraction by a number that's going to deal with the denominator, okay? That sounds goofy. You're going to multiply the whole fraction by the number 1, but it's going to be a special one to deal with the problem in the denominator that we have. That's a little better. So that number is going to be 42. Hopefully you recognize that 42, 6 can go into 42 and 7 can go into 42. And here's the goodness that'll happen. So if I multiply the top by 42, I get 42. If I multiply the bottom by 42, I got to rock a little distributive property, but that's okay because I get 42 over 6 gives me 7, and 42 over 7 gives me 6. So I end up with 42 divided by 13. And I'm going to stop there. I'm going to leave that. And now I'm going to go back and see which one of these is going to work out the same way. So I can plug in 6. I'm sorry, 6 wasn't what I plugged in. I can plug in 4 because that's what I guessed. And when I put a 4 here, I get 2 times 4, which is, 2 times 4, which is 8. 8 plus 5 is 13. And then down here, when I plug in 4 squared is 16. 16 plus 5 times 4 is 20. So 20 plus 16 is going to give me 36, plus 6 more is 42. This is so close, but yet so not what we want. So you can see that this part would need to be at the bottom and this part would need to be at the top. And here is the right answer. I could talk about this algebraically, but basically it involves doing all the junk we just did, but without the numbers. So when I look at, and I'll just talk about it really quickly. When I look at 1 over all this nonsense, what I realize is that I really want to get rid of all the nonsense. So my special one that I multiply the top and bottom by is going to be x plus 2 times x plus 3 over x plus 2 times x plus 3. What that does is that means that I'm going to multiply. So this is 1. This is really effectively a number 1, but it's a special one that's going to allow me to do some neat things. So 1 times this is going to give me what you see, x plus 2 times x plus 3. And then 1 times the denominator, I'm going to have to rock distributive property. Boom. Boom, right? Multiply this times that, I'm going to get x plus 3 because the x plus 2 is going to cancel out up at the top, right? And then I'm going to multiply this times 1 over x plus 3, and I'm going to get x plus 2. And you see how nicely this happens in the denominator. If I join like terms, I get 2x plus 5. And up top, if I rock a FOIL method, right? Well, not really FOIL method. Yeah, it is FOIL method, or the extended distributive property. Boom, boom. I'm going to get x squared plus 3x. Boom, boom. Plus 2x plus 6. And bada bing, bada boom, I get that. Most people don't want to see that. Most people don't like it. But if you felt it, good for you. If not, plug in a number and do the thing. But I know this little 42 over 42 is a little weird, but that is one way we can deal with ugly things that we don't want to deal with. I'm going to erase all of this, so please copy down what you need to do so I can get started with the next problem. So now we're looking at this next guy. I got all this jazz multiplied together is going to equal this for all values of x, and a plus b is equal to 8, which are the 2 possible values for c. So this looks ugly, but this is again distributive property or FOIL method that we're going to use to apply to do this problem. They told us that a plus b is 8, and we're looking for values for, what are we looking for? For all the values of x. So when they say all the values of x, they're just saying these two are really equal all the time. So that's going to be all right. So I'm going to rock the distributive property. I know I haven't given you the answer because I don't know the answer offhand, so I'm going to do it with you. Don't be mad. All right. So we get 15x squared plus cx plus 14. Distributive FOIL method tells me that I get ax plus bx. When I multiply those together, I get abx squared. Ax times 7 is going to be plus a 7ax. 2 times bx is going to be plus 2bx. And then 2 times 7 is equal to 14. So that's what I have here. Over here, I've got 15x squared plus cx plus 14. Now check this out. The interesting thing is that the coefficients of like terms need to be equal. So you see that the constant 14 and 14 is the same thing. That's good. That doesn't help me, but that's good. That tells me we're working with the same thing. 2bx and 7ax are both coefficients of x terms. So what that means, I can rewrite this a different way. 7a plus 2 times x. Imagine if I use distributive property, I just had to go back because I started yapping and some of the stuff I said was wrong. That's not 7a plus 2. It should be 7a. Let me move this over a little bit. It should be 7a plus 2b times x. And if I use distributive property, I get that. So these guys are gone. Let me go back. And like I said before, whatever the coefficient of the value is, it's got to equal the same value. Does that make sense? Like the coefficients need to be equal. So I got that. And then what I have is that a times b has to equal 15 from that because they're both coefficients of the x squared. So if a times b is equal to 15, and then we go back here to this little mystery, a plus b is equal to 8. What 2 numbers, let's figure out a and b, and then we can go back and figure out c, because you see how c is hinges on what a and b is. So now, what 2 numbers multiply to give me 15, yet add up to give me 8? Think about that. What 2 numbers multiply to give 15? So 5 and 3. Yeah, that's it, 5 and 3. But the thing about this is that we don't know which one is 5 or which one is 3. We don't know. So it could be 5 and 3 or 3 and 5, we're just not sure. And that's how we're going to get 2 different answers for this situation. So remember, 7a plus 2b is equal to c. I'm going to plug a 3 in here. If I put a 3 in here for a, if a is equal to 3, then b is equal to 5, then I would get 21 plus 10, which is, what would I say that? That's a 31. If I flip it around, then I get 7 times 5 is 15, plus 2 times 3 is 6. Right? No, 7 times 5 is 35. Sorry, lied. 2 to the 6, then I get 41. And you can see that that's the answer choice that we get. Weird, huh? I can't really think of a slicker way to do that problem. Let me give you the answer to this last one. The answer here is this guy is 12, 2 to the 12, and the way you would do that is crazy. So I'm going to just write the problem out and I'll show you. Since 8 is equal to 2 to the third power, I can rewrite it like this, and then I can rewrite it like this. The rule tells me that I need to subtract exponents, but we know that 3x minus y is equal to 12, therefore replace that.